Well, the arrival of quantum computers could be even more historic than that.
One of the most influential and advanced physicists of our time, Michio Kaku, has shared his perspective on a groundbreaking discovery. Kaku, renowned for his exceptional contributions to physics, recently confirmed that the James Webb Space Telescope has unveiled 6 enormous galaxies, which many scientists had previously thought were impossible to exist. These findings could potentially open up new perspectives on our knowledge of the universe, making them both exciting and crucial to follow. Kaku is an outstanding figure in the scientific community, a physicist with both Japanese and American roots and an expert in classical experimental physics as well as quantum mechanics. Unlike some more conservative scientists, Kaku is not part of that group and has embraced the incredible results of the James Webb Space Telescope mission. It's exciting that this highly regarded scientist has chosen to break his silence and publicly share what can no longer be ignored. The enthusiasm, even a touch of amusement, is apparent in his comments about the discovery made by the telescope. He expressed that this has emerged as a crucial highlight that piques his curiosity. Come along with us as we explore the implications of Michio Kaku's reflections upon discovering these 6 enormous galaxies. Kaku is a researcher who has consistently been open to considering new ideas over the course of his career. He acknowledges that the equations of Einstein's and Newton's laws of relativity are insufficient to adequately convey the vastness of the universe. Kaku acknowledges that the James Webb Space Telescope's discoveries have the potential to greatly enrich the scientific discipline. Even though many of his peers have been unable to embrace this point of view, it has caused concern and anxiety among proponents of the Big Bang Theory and some supporters of quantum mechanics. However, this merely entertains Michio Kaku. The JWST has shed light on the existence of 6 massive galaxies dating back to the universe's earliest periods. These galaxies contain more stars than the Milky Way, formed only 200 to 700 million years after the Big Bang. The experts in astronomy have appropriately named this discovery these remarkable galaxies universe breakers, since confirming their existence would completely change our comprehension of the universe. Something here doesn't align with what we thought we knew. The Big Bang Theory tells us that the cosmos was in a chaotic state right after the initial explosion. It took several 100,000 years for solid objects to form, and additional millions of years for them to accumulate sufficient density and begin emitting light. The formation of complex structures like galaxies was assumed to happen much later. Yet some of the newly discovered galaxies greater in size than the Milky Way, and their extreme luminosity suggests they were most likely forming new stars at a much faster rate than the formation of our own galaxy stars, which form less frequently. Researchers are still unsure of when the initial galaxies emerged. So far, the only certainty is that initially there may have been only isolated stars or small groups of stars, which later combined to form larger accumulations, ultimately resulting in dwarf galaxies. These small galaxies collided with one another, steadily expanding into larger ones. Theoretically, in the past, large organized galaxies couldn't have occurred at such a young age. Raising the query, is the universe a lot older than we believed, or did complex galactic structures form earlier than expected? This scenario is difficult for conservative science to accept, which still faces challenges in reconciling this model. Some physics fields are resistant to this discovery, questioning the accuracy of age calculations. Kaku is conscious of these difficulties and commented that many outdated and incorrect theories persist due to the prestige of certain scientists. These theories were only found to be false when critical experiments revealed their flaws. According to Kaku, the core of scientific progress, particularly in physics, relies on experimentalists who ensure theorists remain accountable. In reality, we know very little about the true universe's beginnings. The Big Bang Theory was first proposed in 1927 based on evidence from observations that the universe was expanding. These observations led to the idea that the universe began from a singular point and has been expanding ever since. That concept was difficult for individuals, including scientists, to conceive of a universe that had a beginning and an end. They could not comprehend the notion of an infinite, eternal universe. Even scientists continue to wrestle with fully understanding this concept. However, it is essential to keep these possibilities open. Again, these brand new results contradict the foundation that researchers have relied on for decades, based on the Big Bang Theory. Yet science has repeatedly demonstrated that reevaluating pre-existing ideas and being open to new concepts is a vital aspect of scientific progress. The confirmation of theories through observation is a continuous procedure. When Einstein was a child, people were taught that stars and planets were fixed in place in the universe, occupying definite positions. However, we now understand that everything in the universe is moving. Planets orbit stars, stars move within. Galaxies at hundreds of kilometers per second, and galaxies themselves move rapidly through space. Their ultimate fate remains uncertain. Today, scientists are coming to terms with erasing uncomfortable truths, realizing that theories are merely speculations and not facts that cannot be changed until they are thoroughly tested and supported by precise observations. The Big Bang Theory emerged from the realization that one galaxy is being displaced by another, moving at a rate proportional to their distance from Earth. This observation, known as Hubble's law, asserted that the universe is expanding. Additional evidence from elements like the cosmic background radiation and the redshift of light from distant galaxies reinforce this theory. However, it is essential to remember that in the past, people who believed the Earth was flat and that the Sun revolved around us also had evidence supporting their views until new observations or advancements in technology resulted in a better comprehension. We find ourselves in a similar situation today. Scientists expected the new James Webb Space Telescope to utilize the Big Bang Theory's assumptions. But instead, it discovered 6 galaxies that defied expectations. This reminds us that science is ever-evolving, and scientists must remain open to new discoveries and reassessing existing theories when new evidence emerges. Researchers rely on redshift as a method to determine a variety of cosmic quantities. Redshift, also known as the Doppler effect, refers to the change in the color of light as it moves from the source relative to the observer. Imagine standing still and hearing the sound of a car approaching you. As the car gets closer, the sound becomes louder. However, when the car moves away, the sound shifts. Likewise, when a light source, like a star, moves relative to us, the light shifts towards the blue end of the spectrum as it approaches and towards the red end as it moves away. Redshift is the name given to this phenomenon. Physicists use redshift values to calculate velocities and distances in cosmic measurements. However, it's crucial to acknowledge that even small errors in these measurements can have significant repercussions. The techniques for measuring that have been used thus far are currently being evaluated. And it will be interesting to see what conclusions researchers draw from the new information. As for the latest revelations, we must consider whether they are truly based on redshift errors or if some scientists are simply refusing to acknowledge the truth. This question demands thorough analysis and a reanalysis of the data and methodologies used in the research. I appreciate you watching this video. As always, we recommend that you post your ponderings or inquiries raised in the comment section. If you liked the video, don't forget to hit the like button, share it to reach a wider audience, and subscribe to the channel to avoid missing out on future content. Thanks again for watching, and we'll see you in the next one. Recent developments and discoveries in space exploration teach us that the scientific community should remain adaptable and flexible to change. New discoveries frequently pose serious challenges to established theories and beliefs. This is demonstrated by the James Webb Space Telescope's remarkable information about the 6 massive galaxies, an ongoing process of reevaluation. As we continue to study the cosmos, we should remember that the universe could be significantly more intricate and enigmatic than we previously comprehended. The nebulae revealed by the telescope, which are much earlier than traditional models would suggest, might necessitate changes to many of the ideas that we've long taken as a given. This new development is not merely an anomaly, but rather a significant event in the history of scientific progress. Scientists, including Kaku, emphasize that our understanding of the universe is incomplete, and each new discovery only adds layers to the ever-evolving narrative of the exploration of the universe. The resistance that some scientists in the community's reaction to the new findings is common throughout the history of research. Frequently, paradigm shifts face doubt from those who are invested in the old designs. Nevertheless, Kaku points out history is full of instances where theories that were once accepted were eventually replaced or altered following groundbreaking experiments and observations. It's this willingness to embrace alterations and discoveries that has pushed human knowledge forward and permitted us to comprehend the universe in significantly more meaningful ways. The significance of these new findings is not just in their challenge to existing theories, but also in their capacity to open up new possibilities for studies. For instance, comprehending how these massive galaxies formed so early in the universe could lead to a rethinking of galaxy formation processes. It might even necessitate changes to cosmic evolution models, especially concerning the rate at which galaxies grow and change into stars. Even more, when the data comes out, we might be one step closer to a new era in cosmology that challenges the very foundations of what we pretended to know about the universe's background. Kaku's perspective on the matter is crucial because of his willingness to embrace new evidence and ideas, regardless of how disruptive they could be. His awareness of the significance of the James Webb Space Telescope's discoveries reflects a broader change in scientific perceptions toward more openness and flexibility in the face of newly acquired data. The scientific community has used rigorous testing and empirical data to make decisions. But occasionally, as we can see, the data may lead us to unexpected places that force us to reconsider everything, even the most basic assumptions. In the end, the work of scientists like Kaku is a reminder that knowledge acquisition is ongoing. We are constantly on the lookout for new data that might reshape our understanding of the universe, whether it is through new telescopes, more advanced instruments, or novel theoretical frameworks. The journey to uncover the secrets of the cosmos is far from over. These most recent results will likely be just the beginning of an exciting new chapter in the field of astrophysics. As we proceed with this voyage of discovery, we must keep in mind that science is an ongoing process, motivated by skepticism, curiosity, and primarily a never-ending pursuit of truth. The information provided by the James Webb Space Telescope is more than just the work of a handful of astronomers, but a component of a greater group effort to unlock the universe's unsolved mysteries. Every new piece of data completes the picture, and each new discovery opens up new perspectives, which allows us to view the universe. This exciting time in space research exploration encourages us all to remain engaged with the wonders of the universe. The inquiries that Kaku and his peers pose serve as a reminder that there is much more to learn and discover. Perhaps, as new findings emerge, we will see even more shifts in our understanding of time, space, and the very essence of reality as a whole. The journey is only just beginning, and where exactly these brand new insights may lead us in the future is unknown. Thank you again for following along in this exploration of the latest advancements in space science. We encourage you to keep asking questions, keep searching for answers, and above all, keep looking around. Our understanding of the universe is in ongoing development, and with every new discovery, we move a step closer to comprehending the amazing vastness of the universe. The consequences of these findings are profound, not only for our comprehension of the universe, but also for larger philosophical inquiries that have long intrigued researchers and thinkers. Humanity has, for centuries, inquired about the universe's origins and its true nature. The idea of the Big Bang has played a crucial role in explaining how the universe got its start. However, these new discoveries question that view. The galaxies discovered by the James Webb Space Telescope indicate our universe could be far more complex and older than we had anticipated. This shift forces us to reconsider everything from the formation of galaxies to the fundamental structure of the universe itself. As Michio Kaku and others in the field of science have pointed out, the manner in which we approach these new discoveries with an open mind is a method of constant questioning, testing, and refining ideas. What we once believed to be true may no longer be true as new evidence is discovered. The skepticism these newest revelations provoke is a natural part of the scientific discovery process. And while it can be uncomfortable, it's an essential part of pushing the boundaries of knowledge. The exhilaration, however, is reflected in the eagerness of those who investigate these oddities and their implications for our understanding of the early stages of the universe. It's worth noting that galaxies discovered that formed so early in the universe pose significant obstacles for existing models of cosmic evolution. As these issues continue to challenge us, innovative discoveries' implications extend far beyond just galaxy development. The finding of these 6 massive galaxies that are much older than previously thought possible could drastically alter the way we understand the universe's very fabric.